Welcome back to Neuroconvergent Leadership, where we talk about effective communication and leadership, especially in the STEM workplace. I'm Jeremy Doran, and I love to help great engineers become great leaders. Today, we have John Peterson with us. John, welcome.
Hello.
It is great to have you here. Sometimes I try to explain what someone does, but I will let you do that for yourself if you can just give a quick explanation of what you're doing.
Sure. Data center design manager. What that means is put together the teams and make sure that you can get a project done on the design side. And then, of course, you might be looking at just a piece of dirt and where do we get power, where do we get water, where do we get all these things in order to make everything happen on the construction side and hopefully deliver a final project as part of that team.
So, are data centers an important thing these days?
Yeah, a little bit in the news lately. Good or bad depends if you're the local neighborhood where a facility's going in or not. But yeah, it just feels like it keeps growing year by year. Around the pandemic, everybody was like very thankful because suddenly we had all this infrastructure that was already built out on the telecom. And if it wasn't there, we'd be scrambling on that still probably today. But a
Mhm.
lot of that build out was already done, fortunately, and that was great. It kept us out of the news for the bad reasons. But of course, AI is coming along, and everybody's just well, what's behind AI? How does this work? How does this operate? What do we need? And of course, the data centers that are going with them are massive, much more massive than the data centers we saw in the past. So it's like an order of magnitude step up on the amount of power, the cooling, and everything that goes into these facilities. So in that way, it feels like, wow, this is an explosion of growth, and that gets a lot of attention. But meanwhile, it's kind of we need to keep heads down on what the requirements are. Are we really focusing? What needs to happen? And how do we solve some of the other issues so that we, stay out of the paper for the bad reasons, but also like how do we help out in the community things that we already knew about? We don't have like communications directors for the industry that say, oh, hey, data centers are a good thing, and here's why. But I've always looked at data centers as being among the more efficient facilities on the planet, and that's usually because the watts that they're using are applied oftentimes for the compute that's needed or what we're looking at just to run things. It's not necessarily wasted energy. If you compare it to like an office building or an industrial process, and you look at the amount of losses that they have, and oh, we have unoccupied times, et cetera, you suddenly see like, wow, data centers are really an efficient use of every watt that we have. So, it's one of those like, how do we sell that? How do we like package that and like tell the neighbors, not only are we helping out with your taxes, but we're helping out with just efficiency overall too. So, I guess that's the next challenge that we might see over the next few years. Yeah.
Yeah. So, a couple of interesting things is there's the not in my backyard phenomenon. People definitely want the data centers. They definitely want the AI. They want the connectivity. They just don't want the thing, so that they can see it. Um, Out of curiosity, how much of the stress is on the data centers themselves and building them out versus the infrastructure of getting data from one place to another? Is there a strain on both sides, or is it mostly explosive on the data center side itself?
I think it's both to different degrees. I think a lot of that is just where are we getting power? That's one of the big things that's come up over the last couple of years. And those power allocations, I fielded calls from people that are like, well, I'm in Texas and I've got this 345 kilovolt line running through this property that I own or this option that I own. And that's great. But have you done a power study on it? Like, can we pull down from that? What's a substation? What are the step downs from there? Have you looked at this at all? Well, we were going to build some housing, and well, how many houses? Well, about 100. That's a lot. And I'm like, not to a data center power use, like let's rethink that. And you start to give them some numbers. And within like the start of the call to like an hour later, they realize, oh, I need to do my homework. I need to go figure these things out. A lot of that has been happening through the industry. It feels like, like, look, I've got power options that we can go ahead and look at, but I feel like a lot of the industry has gone ahead and said, where is those major power supplies? When is it coming online? What are the transmissions? And it feels like across all of the utilities, they already know or have been approached. Their doors have been knocked on a lot by all these data center providers, and they're like, look, here's what we told the last guys. It's the same thing. We're not going to have power for another 3, 4, 5 years, and that's if everything lines up. But the thing is, like, a lot of those data center providers, they just want to know, like, well, we're here to help solve your problems too. We don't want to tell you how to do your job, but man, like, let us get into it. And they will hire consultants themselves and bring all that knowledge and try to figure things out with them. It's one of those things of like, you hear about disruption and how can we disrupt the utility market as well. So there's that side of it. And then also just on the telecom and how do we make sure that all of that happens as well. I think a lot of those telecommunications have already been put in. And again, that's really fantastic. Now we're looking at all of the data center side and making sure that we have the power, the space, the cooling that can go with everything to make sure all of that happens. So the next time somebody does a chat GPT search or whatever, it's not taking super long, and it's also going to be more and more correct because those
Mhm.
training facilities are getting better and better and better, where those models that we're finally going to get, we can start to trust them. We could say, you know what, I can rely on this. How many fingers am I holding up? Yeah, it's 4 this time. You got it. And we can do that 10 times in a row, and it gets a 10 out of 10. Right now, I'd say we're 6 or 7 out of 10. And quite frankly, that leads to AI not being trusted, right? A lot of people are just like, forget it. We don't want to use it until it's done. It's fully baked. Totally get that. And that, I think, is a lot of where that, hey, there's an AI bubble, it's going to burst. We get that, I think. A lot of people get that. But, on the flip side, like, wow, 6 or 7 out of 10, right? That's fantastic. And it's doing so much work for you. All you have to do is pivot and check on the answers. You don't have to do all that homework yourself. It's starting to be helping a lot of different industries, including the data center industry, and how do we arrive at power, space, and cooling for ourselves. Let's leverage AI wherever we can for that as well.
So, can you explain to me more specifically what your role is? Are you the one who's interacting with a number of different factions, or what is it that you're doing on a day-to-day basis?
Yeah, there's not just like single decision makers ever. It feels like there's always teams, and it doesn't matter which company you're looking at. Um, there's usually a team that's going around, hey, this is how we're designing something. There's another team that's looking at land, and what's going to be sufficient for that. They're doing all the studies that work with that as well. But then there's other teams, like procurement teams and hardware teams and software teams and network teams. And they're all looking at how do we make sure that we can pair this up? What are the ratios that we're looking at for, say, GPU to compute? And how do we then aggregate that up in a network? How does that network look like? And how does all of that get stuffed into the big data center facility box? So that's where I come in and say, okay, are these numbers right? What are the requirements that we're looking at? Can we run hotter? Can we run more efficiently? What are some of the other things that we sort of push the boundaries on? Or what do they say, hey, we really need this and we need more of it. And you're just realizing the density that's going in is not what we've seen before. So suddenly you're twice as much on the power that's going into the same area. And that means we're switching over from things like air cooling was a norm for like a lot of cloud compute. And that's what all of the co-location providers were sort of aiming around, 5 years ago. Now it's switched over to liquid, and everybody has pivoted pretty quickly on that. But there's still a ratio of how much air, how much liquid do we need? Everybody's a little bit different. What's that going to be? And that's where everybody on those different teams sort of says, okay, well, it's going to take 2 years to build this data center. What do we have today on the specifications, and what's going to change? Do we
Mhm.
need to be flexible? So if it's a 50-50 air water, do we need to be 75 water, 25% air in the future? We need to have a data center that maybe can be flexible to do that, but also scale. So if you're only starting out with 10 megawatts, how do we scale maybe 10 megawatts at a time so that you can go ahead and figure out, okay, this is what we're installing today, here's tomorrow, and then here's 2030. Same facility, we're going to still use it, as much as possible. How do we make all of that happen on the design side? Teams I'm part of, that's where we come in to sort of say, okay, here's what the goals are. But whenever we're designing this, we're also saying, look, you gave us these requirements. Now we get to set sort of the limitations that we heard. And this is what the facility can do. Look, we have a 30 megawatt, data center. It can do 30 megawatts of IT, but maybe it doesn't have the redundancy that some of the others did, or maybe it doesn't have some of the other features. And that might be like, look, where we were at design in 2025, we didn't need this or that. We were deciding to save money, make it more efficient, whatever. Now, when the next data center comes along, do we need to build a new one? Can we rehab this one? We're going through some of those conversations from data centers that are, again, like a decade, 2 decades ago. They might have liquid cooling, but they're not going to suit what we need. So it's all those things like the day to day that we sort of bring around to analyze, figure out what teams need to have certain says, and then how do we filter all that and come out with a data center design.
Is Are government agencies also something that you need to deal with?
The regulatory agencies, yes. I used to do government data centers a while back, but I haven't been involved in that for a few years now. But the way that the regulations are in the United States are different than they are, say, in Europe. In Europe, they're very much like, hey, we need to have all of these regulations to be followed. In the United States, you can find the local jurisdictions, and that's a lot less restrictive. So they want you there. They want to be able to help out, and they say, look, we don't really know what we're looking at, but yeah, we trust you guys on like all the power, the space, the cooling, but you're following all of the codes for fire protection, fire alarm, all the safety codes. And that's oftentimes what they're worried about is those kinds of things that are life safety, as opposed to, well, your data center might not be the most efficient. They're not getting into the business of trying to figure that out for us or challenging on that on us, because a lot of those tech companies are just already doing it. They realize every watt that we can save, we're already, it's going to be putting us that much better on performance and that much more ahead.
So I often talk about in manufacturing, there are different groups that need to work together in order to build a product. So there's, marketing to figure out what you need, and there's design, and there's manufacturing, and there's service, and then there's sales. And that's all within one company. And it's incredibly complex to get everybody to work together. And you're doing it with multiple different teams from different companies and getting all of them to work together towards a common goal. That cannot be easy.
Yeah, it's not, but that's a really good analogy though. If you have that understanding, a lot of that translates to how data centers are done. And even though we might have a general contractor or the vendors that we'll be working with to get the equipment that we need, everybody is on the same page with that understanding and pushing things forward to say, okay, we know you want a data center. This is what we're seeing as what you're needing. And they're answering that call. So if we do change something like, look, we need to have something that's a little bit, cooler on what we're looking at, or we need a different temperature difference or supply pressure, whatever, we have different power needs. They're answering that to say, here's what our solution is. And they're not the only vendors and such. There's several that we're working with that will say, we've got a little bit different take on it. Have you considered this? And it becomes more collaborative, but that collaboration sometimes takes time to go through in the design process. So that analogy of having like that, like you have everything under one umbrella, find that that's true for all of the data centers, even though it might be, you might think of it as siloed between different companies. But when you get to the end of, like the design process, you look back and say, oh, well, we had all this input and they were, wide open and transparent that said, yeah, we can't do it, or we don't know yet. And that's fantastic. That to me means, okay, well, we've got something new. We know it's going to be new, but they're solving it. They're helping us get to the end goal. And then when things start to get designed and built, or they go out the door and the general contractor runs into problems and say, well, you didn't think about the constructability on this aspect. I am having a problem. Help us, and they reach out often, which is the other transparent side of, we try to be very much paying attention to that. And oftentimes I look at it as they're our customers. Like that's who I think of as those contractors that are out there building something. If we didn't put the design documents that are thorough enough and have everything in there, that contractor might be lost. And for the industrial process, it might be the same way. Like manufacturing this, wow, we got a flaw and we made 10,000 of them. Well, you might have a big loss there, but for us, we have one piece of equipment that might be replicated 10 times. That's a huge loss because the equipment is just so massive. So that is also a big loss. So you just want to make sure that, hey, well, we bought 10 of these. Now we need to go back and redesign around them. We don't want to do that. Sometimes that just kind of comes up. But yeah, it is. Everybody tries to pull back the curtain, be transparent about everything, where they're at, what they're moving forward on. And to me, if people are sort of, I don't know, cagey or passive aggressive, that just does not do. And that to me is the difference between whether you work with them in the future or you're sort of like, hey, we need to let go, and maybe we'll drag everybody to the end of this project, but man, on the next project, we'll have a new team. So it's those kind of decisions we go through. Yeah.
It almost sounds like it's easier working with all the different companies than it is from within one company. Because I know that within companies, the different departments are very quick to point fingers at a different department because they know they're there. But if you are, separate companies and you may not get brought into the next project, then it sounds like they're more transparent and they're more collaborative than sometimes happens within companies. Have you found that?
To a certain degree, everybody has some gossip or complaints. I won't say I'm immune to that, but sometimes it's just like, man, could this process be easier for us internally? Could we get something done? But whenever you sort of like peel back or somebody says, well, this is why we have this and this is why it takes this amount of time, it's because leadership teams have maybe stumbled across something that became an issue. And that issue costs either their team or their company or whatever a problem. And because of that, you sort of, you're scheduling all of that in and saying, well, can we reduce this? Yes and no, maybe if we skip some steps, but the steps are there for a reason internally. Externally, the companies, they also have their processes. They're not just going to be wild, man, like, hey, no problem. We'll just get it done. No problem. We'll just stuff everything together. It is like, we're looking for answers oftentimes, not from the sales gentlemen that are helping us out from the day to day. They realize, look, we're trying to get our engineers to talk to their engineers that are on the floor. So as they're building it, we understand how that was designed and is that going to work for us? So to me, it works out pretty well, especially if we're, trying to get something, the guy that's on the floor can really help out with, well, this is how it's being built. This is how we're going to access the fans or the breakers or whatever components are part of it. And the design engineers and the operations engineers that are going to own it, take care of this thing for the lifetime, they can understand how it's being put together as well in order to figure that out together. To me, that's been a lot more helpful as well. Yeah.
Yeah, that's interesting because very often between, say, departments, I'm just going to call them departments, the only people who really talk to each other sometimes are the people in charge of those departments instead of the people who are like boots on the ground and actually like doing the thing. They don't communicate as often sometimes. It sounds like you're able to get that done. And, working in companies, have you seen that happen as often as well? Or have you seen it just be kind of like the top people talking and then pushing it down and losing something in translation?
I think it's more like, I think it's approaching more of a Kaizen approach where it's that, the top, the leadership is trying to help everybody else move things along. And to me, it's not necessarily the top level making a decision. They might make a major decision about, like a certain install or a certain technology that ripples across all the teams. And that's where usually like a lot of the teams will just say, look, somebody's got to make a decision about this. Like it's, is that us? We have our recommendations, but we just need a determination. In a lot of ways, like if, there is like like a bottleneck or something like that that seems to be a hurdle, it's where it escalates through like a certain team, but it's not necessarily like, well, I have to go through my manager so that they talk to the VP and that VP talks to another VP and it comes back down the chain. It's usually like diagonal, like, hey, I've got an issue. Like I pass it to my manager. I let them know like what we're seeing and they can go ahead and swing right over and be like, just contact them. Just don't worry about it. Like, just copy me on this communication and it'll be fine. But I think that that's something that took practice over time. It's not something that was automatic, like, well, I got to report to my boss. I got to make sure everything's kosher, everything's cool. I get, approval upon approval. And I think a lot of ways for the years, it's been more of, well, we have that trust and communication. We just need to make sure that we're okay with that, and we follow up with all the documentation and everything, so that 2 months, like, well, Peterson told me this. But wait a second, did I? Where is that email, or what was the communication, just to make sure there wasn't a miscommunication. And that to me means, like, look, let's just all get on the same page. If we have a certain thing that we don't understand about a requirement, or the design has a certain flaw or something like that that we need to fix, we just need to get all on the same page, as fast as we can. Not bother the leadership teams, loop them in, sure, but they might not be the decision makers anyway. They might be like, look, I know what a spreadsheet looks like, or you get high enough up, they're not going to get in the nitty gritty of a lot of these things that the day to day people are still a part of, and basically solving every day.
It You kind of preempted me. I was going to say it takes a lot of trust. It takes a lot of trust from the, executives to trust that the people who work for them are okay to cross over to another company or department. And trust just makes everything so much more efficient rather than having to go up the chain of command over and then back down. If you can trust your people to do the right thing, it's so much more efficient, but it does take building of trust. Trust doesn't just happen.
Yeah, yeah, that's right. And a lot of the junior engineers, or just 5 years out, they're starting to get their sea legs, right? They're getting that, like, hey, I know what I'm talking about finally. And now, like, getting them to trust their own skill to say, okay, if I say, look, that looks good to me, put that together, put a nice executive summary, one or two sentences at the top. You wrote like a 12-page dissertation for us, great. But what I was highlighting is, I throw it into AI, give me the summary, give me the bullet points. What do you think is going to happen on their side too? What do you think their leadership team is going to want to know? Make it right up front. Don't bury the lead at all, and put that together, and be confident about sending that over the fence to that other team or that other company. And if you put your foot in your mouth, like, I'm trying to help you prevent that, but sometimes, like, maybe there is a miscommunication. Maybe we just don't know, enough about a situation, or the design as it's progressing, and we make a mistake, or we made a wrong assumption, and people correct us. That's just part of the job. But, like, I've had some, junior engineers in my career come into my office and be like, I can't believe, like, you let me do this, or I can't believe I've had this happen, man, I'm a failure. Like, maybe it's just that engineering tendency to be very sensitive on those things, because they want to be right all the time about everything. And that communication sometimes opens you up to be wrong. And that part of that, like, let's get over that hurdle and develop that trust. This is my understanding. This is what we need to do to move forward. Here's how we're seeing it on our design side. Let's just communicate that wildly openly, and let that land. And it's okay to back off of that. And look, we have to make a few corrections, but for the majority, it's going to be more helpful than not sending anything, or just sort of designing in the dark and then trying to show up a few months later with something that nobody agrees to, or people wonder, why did we go off in left field with the design?
A couple of recent episodes have talked about psychological safety and the willingness to make decisions. And you've just touched on both of those. You need the psychological safety, knowing that you can take a risk. It may not work out perfectly, and you're not going to be crucified for it. Someone's going to have your back. And then on making decisions, it seems like it's the end of the world. And you talked about a couple where things would need to change and it's expensive, but it's not overcomable. I'm not sure
Yeah.
I'm saying that right. Um, but sometimes people won't make a decision because they're afraid that it can't be fixed. But you never have 100% of the information. You're going to have to pivot as you go forward, because who knows what technology is going to look like 3 years from now or 6 months from now.
Yeah. Yeah, that's important to have that comfort on those decisions. Yeah. And that's where, like, hey, we need to make a decision about this. And sometimes, people are looking around like, well, who's the decision maker on this? And well, we need to pool this and make sure, like, do we have all the stakeholders involved, on this design decision, that we're going to rearrange this, this entire facility or this room or whatever. And it might be a small group, but at the end of the day, it is, like as part of that design management team, I feel like I own those designs of those projects. And that's where I want to say it really comes down to me. And I want to have the back on everyone there. So if my leadership or anyone else's leadership comes down, I feel like I can take that hit. Like, hey, I've got that experience, and people will say, well, you should know what you're doing. But, like every project is different. Some are going to be a little bit different here or there. But the thing is, I feel like I've built up those calluses maybe, or a little bit like it matters, yes. And what matters more to me, though, is are we able to fix it? To your point, is it correctable? Or is this going to be a multi-million-dollar issue? Those are the things that experience has given me, that's why we're designing it as a group where, look, a lot of those engineers are looking at that nitty gritty and they understand, okay, well, here's the cable designs and here's all the conductors and what their sizes need to be. Fantastic. Aggregate it all together. If they're in the wrong location or we're not supporting the power that we need to, it's going to be a major mistake. So how comfortable are we with that? And if that, somebody more junior or they not even junior, but they might not necessarily be comfortable with that decision of like, I think I'm done. I think I'm okay. Okay, well, let me get some help in to review this if you're still uncomfortable about this, because it is a multi-million-dollar thing. If this goes or gets installed wrong and concrete gets poured over it, schedule delay, cost, all of that jazz, and nobody wants to hear any of that. So it is where, okay, I need help, just trying to elicit like, do you need help or do we need to go ahead? Are you okay with what you've got? Because you've done this a few times before. So it's those kinds of things of trying to get that feel for it as well. Again, project to project, it feels like sometimes, oh yeah, we've done a project just like this. And it's that flip side of like complacency of like, okay, wait a second, show me why, this piping is the same or why you think this is the same too. So I feel like there's those two extremes I'm kind of, afraid of, or I guess I've learned over time to watch out for.
So one of the things you talked about a couple of minutes ago was not burying the lead. And engineers are notorious for burying the lead. They want to tell the whole background and all of the details that got them to eventually say what they need or what the answer is. So it's interesting that you mentioned AI as a way to help them not bury the lead.
Yeah, that's what my wife used to say to me a lot was, what's the story here? We got to go in 5 minutes. Are you going to be done by then?
Yeah.
Um, so yeah, it is spending more time, but to me, to understand some of that story of why that decision making process, it's it's interesting because I've gone through that. I've been on that side of it to understand there's an entire process of like, well, I went down this road and then we made a course correction, and then we finally honed in on what we think is the right thing. And they, I used to want to explain all of that too, just to say this is why I feel comfortable about this decision, and to have somebody else understand it and pick that up and run with it, that to me was like, okay, that's what I used to do with my old mentors. Now it's kind of like, well, that's great, but let's summarize. Let's keep it succinct. If you've already been down that road, like it's not that we don't care, but we will go down or we will try to figure that out as needed. We don't necessarily need like all the back history of that. So in a lot of ways, like, hey, we're writing more of a, I think I use the analogy of a magazine. Like we're putting a magazine together, and everybody's got their own, articles. We're not writing a book, and we don't need like 16 chapters on, this particular item with each chapter detailed. So strip a lot of that out when we're doing a lot of that on the explanations, and then again, we're using AI a lot just to sort of get through all of that. But the other part is like a lot of the engineering will be, like a lot of numbers, and we're starting to plug in a lot more of the Excel spreadsheets. So the things that are really hard to describe in words for engineers start to get either described in words with, from AI, which can be wrong. You have to do the course correction there, but it's also just, what are, out of all that big data that we're getting, what really do we need, or what really stands out for us to understand where the anomalies are? So we might have a system designed, but it works in 99.9% of the cases. But dang it, we've got this one case over here. What is it? Why? And if you can pull that out and understand that and get that to be, like with any of the engineering teams, to explain that to management so that, hey, we've got a data center. Are we okay with like a little slip on redundancy over here? Or we've got We want to have less equipment to save money or to save, on the efficiency of the design. Are we okay with this? Like that, what that little extra percentage on the redundancy or availability scheme might be. We haven't done a full analysis on it, but we can. And if we can get AI to sort of pull that out and start to explain that a little bit better, it helps us, I think, convey everything to those other teams a little bit better or a little bit more easily. So again, it gets lost a little bit in the details and noise, but it feels like it's also a process, it's a road, and we're getting there eventually.
So you mentioned that you started as an engineer and loved to give the details. How did you make the progression from where you started to where you are today? What were some of the steps and struggles?
I started out just because I like the engineering of like the physical world, and there's rules and you can have an absolute answer. To me, that was fantastic. It was not subjective like writing or those kinds of things. So I really didn't know how to write those kinds of things until 3, 4, 5 years out of college. And I kick myself, and that's one of the things I give as advice is take that English class, that single English class that you have for engineering, take it and learn from that. Don't sort of cast it aside because you're going to write a lot more than you think you might. Um, anyway, so I like to be right, and the main thing that I started to really get good at was, even though during my younger days, I would be right about it and I could prove that I was right. I had a certain arrogance that went with it, and it took me a while to get over that. Especially if there was a senior engineer there and he would be explaining like, hey, this is how I designed the cooling tower. And I was looking at the math and like, you're wrong. And here's two mistakes I'm spotting within like the 5 minutes that you're talking about this. Like, is nobody else pointing this out? And no, nobody else was, because they're waiting for the end. And then, look, this is a draft. Calm down, Peterson. Like, look, we just need to make sure that we're getting there. And he was in that process as well. It's not that I was wrong or that he was like more wrong or whatever, but the thing is, like, let's point these things out as a team, as opposed to being like, like, hey, my way is going to be better because of this. Fast forward, like so many years later, and I've taken that to sort of say, okay, to understand what those other people are looking at for me, and to direct them to say, look, I don't know this answer. Here's 3 different systems that we might take a look at for this that might provide a solution. None of them are going to be, like more correct than the other until we analyze it. Let's figure out like what's going to be good, better, and best. What's going to be, what might be good for the operations team. They've seen this. They've seen cooling plants or, like power plants like this all the time. It's like the one they have across the street. But here's something better that they can operate, here with a few extra tools, systems. But the best one that we really want to put forward, why is it there? And is that going to be sellable? Are people going to agree to say, yeah, let's do this new type of system or configuration? Or is it going to be too much? And for the data center world, to me, I started getting into that, and I realized that nobody wants to change anything on the data centers until somebody's already done it and it's been useful for like 5 years. So I bring up now lithium ion batteries. Before we were using VRLA batteries, but as soon as people started using the lithium ion batteries, it became the new standard. People got very comfortable with them. And one of those things was, how do we make sure that we're very comfortable with those sort of what we call bleeding edge decisions up front? How do we make sure that that becomes the next big thing and our new standard? Or is it going to be something that, hey, we might think about it, but then we end up backing away from right away? And it's some of those things I've learned through like the time as well, like, hey, this is absolutely the right answer, to say, look, this isn't going to be right. This is maybe right if we're doing everything that we learned, or, as like a science project in, like college, or as our senior thesis. We plug in every single sustainability item that we possibly can. But in the real world, like, look, we're only going to capture 2 or 3 of those items and plug them in because that's what we know and can operate. It's not going to sacrifice anything on efficiency or reliability or some of those other aspects that we'll need. So let's just make sure that we do our homework on that. Again, if we're going to have that good, better, best, why is the best the best? And help us, like as a team, help me really sell that to everybody and all the other teams, so we can not have to worry about that. And I think that also helps with if they understand that, like, well, why didn't you pick my decision? Why didn't you like my design? And sometimes engineers can get very passive aggressive about that, right? Like I used to be like, well, what the hell? You didn't choose what I wanted. Well, you should have done what I wanted, But the first project, I think I had that, I was eating my words because I was like, you know what? They got it done. It was faster to build and it was easier for them to maintain. So that was a hard lesson for me, I think, back in like, I don't know, 2003 or something. But it was, to me, it was, important for me to understand and bring that up for some of those other junior engineers to hear that as well. Like, it's okay, and if they know that they've tried and said, here's the best, here's the reasons why, but that's not the reason that's selected, they can understand like part of that backstory on what the reasoning is between other leadership teams or requirements teams or operations, etc. So I think that that's also important to convey.
Yeah, it's a big growth going from the belief that there's one right answer to other people can be right as well as you being right.
Yeah.
But it takes some learning to get there. So, unfortunately, we are starting to run out of time.
Yep.
So, if people wanted to reach out to you and say hello or ask you questions, how would they do that?
I'm on LinkedIn, so just John Peterson, but it goes by the moniker Green DC Guide. So I do have the Green Data Center Guide website as well. So if you look that up, that's one of the sites that I run, and basically people can reach out to me via the site as well as LinkedIn. Also, my email is jpeterson@greendcguide.com.
Perfect. And I
I
will
won't
put
give
that
my
in.
phone number. Yeah.
No, great. I will put those in the show notes so that people can reach out. John, this has been fantastic. Thank you so much for sharing.
Yeah. Thanks for having me, Jeremy. Yep. All right. Take care.
Hold on.
Yeah.
Thanks for listening to another episode of Neuroconversant Leadership. We're over 100 episodes now. And as mentioned, I'm going to be making some changes. So I would love your feedback on what changes I should make, what things I should add, what things I should take away. Please do me a favor and reach out either on LinkedIn or on my email address, which is jdoran@neuroconversantleadership.com. I look forward to hearing your suggestions. Thanks a lot. Until next time, have a great week.